Hi students, let's see about Coulomb's force. Whenever there is a charge kept ideal, there is no any charge near to the initial charge which is kept ideally, which is Q1, then it will create the electric field around it, but it will not feel any force. What Coulomb said, whenever you are bringing another charge closer to the first one, it may be of positive charge or it may be of negative charge. If the source charge which is taken initially is positive, then if you are taking the positive charge near to the source charge, it will start repelling because they are unlike charges. If this is negative and you are taking a negative charge closer to the Q1, then that will also get repelled by the charge Q1. So both are like charges means they will start repelling each other. If we are taking opposite charges means unlike charges, then they will start attracting each other. So whenever you are taking another charge closer to the first charge which is kept ideal, then it will start feeling a force in between. Until and unless if there is no disturbance around the electric field of the source charge, then it will not feel any force. But if you are taking any charge which is closer to the first one, whenever it comes closer to the first one, then it will start experiencing the force. That force is known as Coulomb's force. So is it clear? So whenever we are taking two or more charges closer to each one, then they will start feeling the force in between. That force is known as Coulomb's force. Here we will study about the Coulomb's force and its equation. I kept the charge Q1 initially at rest and I am taking the Q2 closer to the charge Q1. And the distance between the two charges is taken as R. R as a distance between the two charges. Then Q1 may act on Q2 or Q2 may act on Q1. It is same because Q1 can make a force on Q2 or Q2 can make the force on Q1. So whichever you are taking the initial case, first what I am taking is Q1 acts on Q2. What is the first case? Q1 on Q2. So when Q1 on Q2, force is experienced from the Q2 charge is known as F21. It's a vector quantity, so vector. On to due to the 1. So on to F2 due to 1 vector, F21 vector. What Coulomb said, this force will be directly proportional to the magnitude of the two charges and inversely proportional to the distance, square of the distance between the two charges, which is r square. Why? Because I took r as a distance between the two charges, so 1 by r square. If I combine both the equations, what I will get? F21 vector is directly proportional to Q1 into Q2 and divided by r square. As it's a vector quantity, I need to be very careful related to the unit vector also. Here I am taking a general term which is r vector as a unit cap and Q1 to Q2. So what is the direction of the unit vector will be? From 1 it starts and it ends at 2. So R12 is the direction of the unit vector R12 cap. When you are taking the force on 2 due to 1, you need to take here R12 cap, just opposite. 2 1 means 1 2. Okay. Similarly, if I take the force on Q1, Q2 on Q1, then what may be the force value? F12 vector is directly proportional to Q1 and Q2 and inversely proportional to the square of the distance because the distance between the two charges is going to remain same. First case what we took? Q1 on Q2, so Q1 to Q2. Next case what we are taking? On Q1, the Q2 what the force exerts. Okay. So F12 vector is directly proportional to Q1 and Q2 divided by r square. And what may be the unit vector's direction? R21 cap. If I directly proportional, I am replacing with the value constant k, then F21 vector can be given as k into Q1 Q2 divided by r square into R21 cap, as well as F12 vector can be given as k into Q1 Q2 divided by r square into, here 1 2 cap and here 2 1 cap. Okay, we know the distance remains same. the unit vector if r12 cap can be given by changing just the direction r21 cap. As the unit vectors, whenever the direction changes, the unit vector force direction changes, unit vector varies only in terms of magnitude, which is opposite to the previous one. Then we can write the f12 vector is equivalent to minus f21 vector. Thank you.